So what's up, guys? Welcome to Venom Pronov Academy, and in our today's vid we are simply going to look at sets of numbers. Remember, when we initially introduced set theory, we said we are going to look at different subtopics, and our today's focus is going to be on sets of numbers. Now, I want you to realize that there are different classes or classification of numbers based on their properties, because we said for something to be regarded as a set, then it should possess elements that have the same properties, right? Now, when we look at sets of numbers, numbers are going to be classified or grouped into different sets based on the properties that they possess. But then, when we follow the route and go down to where the numbers are emanating from, we realize that we only have two basic types of numbers, okay, or sets of numbers. And these are going to be real numbers and complex numbers, okay, real and complex numbers. Now, real and complex numbers are simply going to be supersets of multiple numbers or multiple sets of numbers. Why do I say so? Because when we look at real numbers, we are going to have a lot of different classes of numbers, or a lot of subsets, so to say, that are going to be grouped. And when we look at the general overview of those numbers, we realize that they are contained inside real numbers. Complex numbers, of course, is going to be a topic on its own independently, and we are going to look at it as the last thing of under set theory. So in our today's video, let's simply focus on real numbers. Now, what are real numbers? Someone would love to know what real numbers are. So real numbers are simply values that represent a point, or a point along a line, or simply values that can be represented along a number line running from negative infinity to positive infinity. So when we look at all these numbers that can be represented along a number line running from negative infinity to positive infinity, then we realize that what we are simply going to so when we look at these numbers that can be represented along a number line, we realize that all these numbers belong to real numbers, okay? So there can be different classes of these numbers, but the fact is these real numbers are going to be running from negative infinity to positive infinity. So each and every number that you can think of at this particular point in time, be it a negative number, be it a decimal, be it a fraction, be it a big number or a small number, they all belong to a set of real numbers. Okay, and they are running from negative infinity to positive infinity because we do not know where the negative starts from or the positive ends from. So all those numbers that you can think, they're simply incorporated into this expression. So real numbers is quite a very big set with a lot of subsets, and the subsets of these of this set are simply what we are going to look at. So if it contains a lot of subsets, then what do we say about real numbers? We say the real numbers are simply a superset. Okay, the set of real numbers is simply a superset of a lot of subsets, such as the natural numbers, the whole numbers, the prime, the even and odd numbers. Yeah, so this is what we are now going to look at. We are going to look at the subsets of real numbers, and our first one is simply going to be natural numbers. I know the word sounds fancy, natural. Yeah, natural numbers. So by definition, natural numbers are simply going to be numbers that do not have decimals and they are bigger than 0. Others are simply going to say natural numbers are simply counting numbers excluding 0. So whenever you think of numbers starting from 1 going all the way up to positive infinity, because we do not know where numbers end, that's the reason why I'm saying positive infinity. So going all the way up to positive infinity, 1 all the way up to positive infinity, it's going to be a set of what? A set of natural numbers. So it's going to be represented by the capital letter N. And then we open the set and put 1, 2, 3, 4, and then it continues to go because we do not know where the numbers ends from. So it will go. If you wish to continue, you can do as wise. So when we look at the second subset of real numbers, we call it whole numbers. Okay. So whole numbers by definition are simply going to be natural numbers including 0. So whenever we think of natural numbers and we decide to take 0 into consideration, then that changes and becomes a what? Becomes a whole number. So this is going to be represented by a capital letter W, and it's going to be running from 0 all the way up to positive infinity. So now these are going to be whole numbers. Remember what we said on the aspect of subsets. We said there sometimes exists a situation where all the elements that are in one set are also there in another set, but at least one element is in another set and not in the other one. And we call that notation as a subset, okay? To be specific, a proper set. So if N is a proper set of W, or natural numbers are a proper set of what? Whole numbers. Why? Because all the numbers in natural numbers are also, all the elements in a natural number set are also there in the whole number set, but 0 is not there in the natural number set, but it's present in the whole number set. So the expression would be like this: n is a subset of what? This. I hope you guys remember this. So the third one is simply going to be integers. Now, I know this is not the first time you guys get in this word. I mean, we are so familiar with this word, right? So integers are simply negative or positive whole numbers. So when we look at this set of numbers that we are from describing up above, then we consider even the negative ones. Then we form a set of what? Integers. And it's simply going to be represented by this. So it's going to start from negative, let me say negative 4. I'm not saying it starts from negative 4. It can start all the way from negative 20, negative what. So we do not know why it starts from. So it would even be right to say it starts all the way from negative infinity going to positive infinity, provided we even include 0. So let's say negative 3, negative 2, negative 1, 0, 1, 2, going all the way forward. It does not start from this side. I repeat. The fact that I've put negative 4 doesn't mean that's why it starts from. It starts all the way from negative infinity. Whatever number you think of is going to be an integer. So the fourth one is simply going to be, and now before I go to the fourth one, I want you to realize that when you look at these numbers that I've written up on top, all the numbers that we've discussed here, especially the whole numbers, you find that they are going to be a subset of what? A subset of these integers. So it's also right to say whole numbers is a subset of what? Integers. So let me quickly rush to the fourth one. So the fourth subset is simply going to be prime numbers. Yeah, prime minister, prime numbers, you know, the prime suspect. So prime numbers are simply going to be numbers that only possess two factors, or numbers that only contain two factors, in that only one and the number itself is what can divide into that number without leaving a remainder. Okay? So prime numbers are simply natural numbers that can only have two factors. Let's not forget the fact that these numbers are natural numbers. So remember, natural numbers are counting numbers, excluding 0. So when we think of prime numbers, we're talking about a number possessing two factors. That's 1 and the number itself. So is 1 a natural number? Is 1 a prime number? No, 1 is not a prime number. Why? Because 1 only has one factor. Only 1 can go into it. If we divide it by 2, then it doesn't work out. So 1 is not a prime number, guys. It is not a prime number. Okay? So this set is simply going to possess 2, 3, 5, 7, 11, 13, and it will continue going. I hope you guys get the trend. 9 is not a prime number. Why? Because 9 is going to possess three factors, 1, 3, and the 9 itself. Okay? 15 is not going to be a prime number because it's going to possess 1, 3, and 5, and 15 itself. So it's going to possess 4 factors. So when we talk about prime numbers, we are looking at natural numbers that only have 2 factors. That's 1 and the number itself. So let's go to another subset of real numbers, which is even numbers. To be even. Yeah, a lot of people actually use this word, especially those people that die in the flat-in phase. Like they'll be like, we are even, you and I are even. But yeah, that was just me adding a little bit of caveat. Yeah. So even numbers are simply going to be integers which can be easily divided or easily divisible by 2. Or these are integers that are easily divisible by 2. And they yield no remainder. So anytime or whatever particular point when you get a number, an integer, and divide it by 2 and it gives you no remainder, that number is going to be regarded as an even number. So they are simply integers that can be easily divisible by 2 and yields no remainder. So these numbers include 0, 0, 2, 4, 6, 8, 10. So this is a set of going forward. They will continue going 12, 14, 16, 18, 20, 22. Yeah, you guys get it, right? Yeah. Then the other class of numbers is going to be odd numbers. Yeah, I find this word a little bit funny because odd means something eccentric, something weird. But yeah, we are dealing with numbers. So let me just say weird numbers, right? Eccentric numbers. So odd numbers are simply going to be an integer which is not a multiple of 2, or integers which are not multiples of 2. If these numbers are divided by 2, they are going to be expressed as a fraction, okay? Or they are going to yield a remainder. So these numbers are simply any integer, and we said an integer is a positive or negative whole number. So odd numbers are simply going to be any integer which when divided by 2 is going to leave a remainder or is going to be expressed as a fraction. Okay? So these numbers are simply going to start from 1, 3, 5, 7, 9, 11, 13, 15. You realize now that there's a similarity between prime numbers and odd numbers. If you're not careful, a lot of people tend to confuse these two. So I want you guys to be extra to pay attention and to be very meticulous when you look at these two different sets of numbers, okay? So this is how it's going to go. When you look at odd numbers, just think of any number that cannot be divided by 2. When you look at prime numbers, think of any number that has got 2 factors, 1 and the number itself, right? Let's not confuse the two. The 7th one is going to be a class of numbers that I'm so in love with. We call it rational numbers. Yeah, you gotta be rational, you know. Rational numbers. So rational numbers are simply numbers that can be expressed in the form of a over b, such that a and b are members of integers, and b is not equal to 0, and a and b do not have a common factor. In short, they are in their lowest terms, so they can be expressed as a fraction, remember, in the form of a over b, such that a and b belong to a set of integers, and b should not be equal to 0. Why? Because if b is equal to 0, then the entire fraction becomes undefined. We are going to look at this when we start dealing with functions. It becomes undefined, and these two should not have a common. In short, they should be in their lowest term. Let's say if you've got 3 over 15, this is unacceptable. Why? Because these two have got a common factor. 3 into 3, 1. 3 into 15, 5. So it should be left in this, or at this particular point, where there is no other number that can go into these two numbers, okay? Now, the decimal part of rational numbers is always going to be reoccurring, okay? What I mean is, if you divide 1 divided by 3, you find that the answer is going to be 0.333333. So it's going to be reoccurring, right? So we simply say this is 0.3 bar. So whenever you see a bar on top of a number, it shows you it's a rational number, and that number is reoccurring, okay? It means that number is going to continue coming this side, right? So, and the last set of numbers is simply going to be irrational numbers. So if someone is irrational, then there are also other people that are rational, and other people are the opposite of rational. So rational numbers are the opposite of irrational numbers are the opposite of rational numbers. And by the way, these are simply going to be represented by this. I don't know if I'm writing the symbol correctly, but I hope you guys get it. Okay. So when we look at irrational numbers, these are numbers that cannot be expressed in the form of a over b. Okay. And these numbers do not reoccur. You never find an irrational number being expressed as 0.3333. No. When you think of irrational numbers, think of the square root of 2. Okay? When you think of pi, when you think of this, because when you think of pi, it's I think 3.142, and the numbers continue going. They are not reoccurring. Okay? So this is what we mean when we talk about rational numbers. So thank you guys for tuning into this vid, and I hope it helped. And if it did, please don't forget to subscribe, and don't forget to leave a comment, just in case there's something that you're not very pleasant with. You can leave a comment so that we know how we might serve you better.